Hello, this is Dmitro speaking from S4GA. If possible, please confirm that you all hear me. Very good, very good. I see. Hi. I wanted to greet you all today at this webinar that we, S4GA company, we are hosting today for all our partners, customers, distributors all over the world. I'm very happy that you join us today for this, I think, 1.5 to 2 hours webinar. As I see from the list, we today have people really from Africa, from every continent, I think, from the Africa, from Asia, from Latin America. So we are very happy, and I hope that after today's webinar, you will be equipped with more knowledge. So the plan is for today is like this. This is agenda. I will speak about S4GA, about the company, so you all understand who you're dealing with. Then I will briefly go through our products, our projects. After that, I will speak about what is that hybrid airfield ground lighting, system works, how wireless control works. We will have 2 questions and answer sessions, one in the middle and another one at the end of the webinar. And of course, you are free to ask questions using your chat. During the presentation phase, I will not be able to answer them, but my colleagues will, hopefully. And during Q&A sessions, you can ask questions and then I will answer. So we will speak about using solar energy for AGL. We will speak about AGL Interface that S4GA develops and distributes. And at the end, we will speak about benefits of hybrid AGL. Now, if you allow me, I will switch off the video so you all can concentrate on the presentation. Hope you will like it. Thanks again, and let's start the webinar. What is S4GA? S4GA is the company that is based in Poland, in European Union. We design, manufacture, and distribute airfield ground lighting. Company today is owned, 40% is owned by Polish government because airfield ground lighting is a strategic industry in Poland. So government invests heavily in that industry to have its own manufacturer in the country. We and our customers, they usually operate in remote areas or areas where there is no electrical infrastructure or infrastructure is unreliable, such as African deserts, Maldives, or let's say jungles of Brazil. Those are typical places where our customers operate helipads, airports, or maybe they need to illuminate or identify obstruction. For those customers, we deliver products that can operate without supply of conventional electrical grids. Today, S4GA has pretty wide product line. We have 3 groups of products. We have portable lights that are used by our customers to illuminate, as I said, obstruction, helipads, and airports. And Those products are mainly used to secure occasional night operations. So here our main customer is police, military, air and rescue. So all these guys who require to operate by night from remote areas. Of course, this product is also very popular as an emergency runway lighting at larger airports during, for example, construction or for a contingency plan. Second group of products that we supply is solar lighting. This product was designed as an alternative for cable systems, but it was also designed mainly as a fixed AGL. So this product, when customer requires to illuminate airport or helipad permanently, and for some reason they cannot do it using conventional lighting, then they go for solar. This product can run independently of a solar grid, basically 360 days per year. What is the difference between this product and this product is that here you have wireless remote control and monitoring. So basically the product can be controlled from the tower via radio network. The third and our hopefully the most popular product is a hybrid lighting system that can be powered by both solar energy and conventional 6.6 amp electrical grid. And as I said again, we supply our products to these three groups of customers, so those who operate airports, helipads, or those who need to identify obstruction, aviation obstruction. Today, S4GA serves different customers. We serve both police and air rescue. We work with military forces of different countries. We work with civil airports, regional ones, small ones, and the big ones. We also work with private customers who are not from aviation world, but use aviation for transportation. So here we can, as you can see, that the range of end users who we supply is, I think it covers every possible scenario. Now let's get to major point of today's webinar, to Hybrid AGL. Let me explain again what is that. What do we mean when we say Hybrid AGL? For those of you who are engineers, I think it would be pretty simple picture. So what is Hybrid AGL? Hybrid AGL consists of course, hybrid lighting unit that can be powered by two sources of energy. One is typical 6.6 amp electrical grid, and another one is solar engine. Why did we do such product? Because we see a demand from our customers for a solution that can run independently from conventional electrical grid, but also in case of, let's say, if there is a long time no sun, right, or in case of failure of this power source, we can always initiate electricity flowing via conventional electrical grid and supplying power to the lighting unit. Now, the difference between this hybrid lighting unit and the conventional lighting unit is that this unit is also supplied with its own battery. We call it a backup battery. So in case of electrical grid here, it's only used to charge the battery inside of the unit, but not to power the unit. So even in case of a failure of conventional electrical grid, we still have a battery inside of this unit that will power the unit and will immediately switch on a backup UPS that will power unit. So there is actually no risk of losing the system because of power failure. So again, there are actually three power sources. One is 6.6 amp. Another one is solar engine. Solar engine has a battery inside. And the third one is a battery inside of the lighting unit. So it makes this system extremely reliable comparing to conventional lighting that we all know. Are there any questions at this stage? Maybe some of you would like to clarify. I will be happy to ask. Okay, good. Good. If there is no question, then very good. Hybrid lighting. What is hybrid lighting unit? Hybrid lighting unit, it's the model, we call it XS1000. And its key features are, it's of course equipped with ICAO compliant optics. S4GA has its own optical head that we design and that we manufacture. This is in order to provide very precise light output and to have light output only where we need it and not, for example, here where we're losing light. This is in order to make this optical head very efficient. It's of course, I didn't mention, but it's of course LED based. So the power consumption is very low. The system or the lighting unit can be wirelessly controlled. It has inbuilt radio module that is working with another radio module that is installed in a tower. So you can wirelessly, by a radio network, you can monitor and control the unit. And there is a backup battery as well installed in here. And it allows for 3 to 4 hours of uninterrupted operation. It's only used in case of failure of solar engine and, for example, electrical grid, conventional one. I see that, I see that we have some questions. Wireless, no, it's not 2.4, it's 868 megahertz. Because this kind of network allows for much bigger range with low power consumption. But I will cover then the topic of wireless network also during the presentation, so no problem. Such light consists about in the highest intensity because it uses about 1 amp of energy at 12 volts. So this is the power consumption, more or less. Typical applications for this light, those are of course not unlimitedly, but runway light taxiway lighting, helipad lighting. You, of course, here you see only one example of one optical head, but for all the lighting, you can have edge lights, you can have threshold lights, and for taxiway, you have blue, omnidirectional. For the threshold, you would have a little different optic that is bidirectional and provides red light in one direction and green light in another direction. Antenna, yes, there is an antenna. Antenna is inside, it's internal antenna in this case. I know that, Alexander, I know that you saw different lighting units with the external antenna, but this hybrid lighting unit has internal antenna. So yes, there is an antenna, but it's inside, you cannot see it. Now we're talking about low intensity light, correct? And solar engine has another battery inside. Yes, you're answering your question. Let's see how the system looks. The typical hybrid system would look like this. You have normal CCR, you have your primary loop, you have isolation transformers, you have lights, you have separately installed solar engine. Now, of course, you are used to this picture, so without this element here. But what is the main difference between this system and the conventional system? In the conventional system, you are controlling light output by changing current. So you basically operate all your computer interfaces out in the tower. You're sending signal to CCR, and you change in current, and this is how you make light. So you change brilliance. In this case, in our case, we do it a little bit differently. So we use, as I said, we use this current only to charge the unit, but we control the unit wirelessly. It means that power of the unit is independent from the control over the unit. Control is done wirelessly. The advantage of this technology is that in case of, let's say, in case if you have low quality or old conventional grid, where let's say changing power is tough, for us it doesn't matter, because we just send signal to the lighting unit and it changes brilliancy automatically. Likewise, here you have in a conventional system, if you want to have a monitoring, single light monitoring, then you have to equip the system with additional module. In our case, we don't need it because we just read parameters of each individual light via this wireless network. Charging by CCR at 6.6 or 2.8 amps. And again, how we do it? We do not run CCR all the time. Primarily, we use solar engine as a source of power because we want to save energy, because we want to save money. So primarily, we run light on this configuration, and only in case if, let's say, battery level will drop below some critical parameter, we can adjust it depending on the customer. For example, we think that for us, if battery is 50%, all below is critical. Then in case we have such critical parameter reached in, let's say, 50% of light, it's a signal for us that we need to switch on CCR. So we send signal to CCR, CCR activates, electricity flows, charges the battery above critical level, and again we have fully charged system and we continue to operate. This was designed like this on purpose. We don't want to run CCR all the time. We want to run it only in case of emergency. So for us, CCR and the conventional grid is basically a backup here. Are there any questions at this stage? Five. There are 5 steps of intensity. Vigo, I will cover this topic when I will be speaking about it in about interface. So you guys all will see how it all works. I think there was also a question in regards to battery life. Yes, the battery life. Wireless coverage. I will also, yes, no problem. So the battery life, getting back to the battery life. The battery, there are 2 batteries installed. One is here, another one is here. Typical battery would live longer if it's being fully charged. If the battery is discharged, deeply discharged, it will live shorter life. So with a solar panel that is recharging battery every morning, it will prolong battery life because the solar panel keeps it 100% charged. In this case, the battery, typical good standard battery, would live approximately 3 to 5 years. But actually, the battery life is calculated not in years, but rather in cycles. So discharge, recharge, it's one cycle. And a good battery, if it's well maintained, will live for about 1200 cycles. So 1200 discharge, recharge cycles. Okay. The wireless coverage, I think Olga has also answered. The maximum distance between tower and the closest light is 3 kilometers. If you ask me, okay, but what if I have the light that is much, for example, on a bigger distance from the tower, I would tell you it's okay, because the signal should only jump to the first visible light, and then it will be retransmitted using another light, and this is how it will reach the last light. So we can actually have light located at the distance of 10 kilometers from the tower, as long as we have intermediary light between tower and this last light, the signal will reach it. If you would ask me also, some customers also ask, is there any limitation on a number of lights that can be controlled wirelessly? To my knowledge, it's 10,000 lights. Basically, in case of even very advanced systems, it's more than enough, because let's take, for example, some regional airport with I don't know, 2-kilometer runway and 2-kilometer parallel taxiway. We would have maximum on a taxiway runway approach, we would have maximum 300 lights, and this system can support up to 10,000 lights. I'm talking about limitations of wireless system. Question is, so can we replace some portion of conventional lighting system using this hybrid lighting? Yes, you can. Because for you, it doesn't matter if it's hybrid or conventional. This lighting unit here, it will operate exactly as your typical conventional light. So if you take a look at this, again, at this schema here, you see that if I disconnect this module, you have pretty classic layout, right? And this is our hybrid lighting. The beauty of it is that it can be supported by both systems, but it depends on the customer, how it all operates. So if you need typical light, you go for our hybrid lighting unit. If you need to save on electricity, you add solar engine. Frangible. This mounting here is made of aluminum. If you see this cut here, it is actually made for the frangibility. But the unit is fully ICAO compliant. I'm talking about optics, I'm talking about frangibility as well. Fernando, I think I did not get your question. You asked me to explain about extra module for CCR control. Can you maybe explain your question? Not sure what you mean here, but let me again explain how it works. In a conventional lighting system, it looks more or less like this. So you don't have this solar engine here, but basically you have CCR, you have cables going from CCR to isolating transformer, and then to the lighting unit. Yeah. So here there's when I say maybe extra, I think I'm not quite clear about what you're asking. But let's say like this. Let's imagine we have an airfield where you have existing grid already. You can use this grid to connect our hybrid unit to it, and also you can add the solar engine. And that I think I don't know if I'm explaining, but in case if it's still unclear, we can always then speak over email or phone. You know how to find me. All right. So I think this was our questions and answers session, unless somebody had any other questions to ask. Right? If not, let's proceed further. So some of you asked and probably were wondering about how the solar engine works. So from this schema here, you see there is a solar engine. It's a completely separate module that is installed not together with the light, but apart from the light. So it's basically if you have a runway and you have a light here, the solar engine can be installed at the distance of, I think, up to 10 meters from the light. And of course, solar engine is also mounted on the frangible legs, so everything is frangible as it should be. Do we have any alternative to sequence approach light? No, we don't have. We do not at the moment. We don't have sequence approach light at the offer. And speaking about IP ratings, Hello, hello. Can everybody hear me? Now you can hear me again. And thanks for waiting, by the way. Good, good, good. All right. So getting back to the solar engine, how it works. So solar engine has three key elements. You have solar panel, you have a charging controller, you have a battery, and then you have a light. So solar is providing energy to the battery, and battery is providing energy to the light. In case of our solar engine, it's big enough to provide up to 100 hours of uninterrupted operation. So even in case of if there is no sun for 2, 3, 4 days in a row, which is impossible, the battery will has enough capacity to power the light during even 1 week. IP rating. Yeah, I mentioned that IP rating of the light is 65. All right. Of course, solar engine that S4GA manufactures can be used not only to power lighting unit, but we basically can power any conventional airside equipment. Doesn't matter if it's PAPI, if it's runway guide light, if it's wind direction indicator, or a guidance sign. Very often we are contacted by airports that, for example, they have runway, they have some remote site where they need to, I don't know, power wind cone, or they need to power a PAPI, but for some reason conventional cable grid is unavailable at this place, or building another loop is too expensive. In this case, these airports are contacting us and asking us to supply them a solar engine that can be placed, installed close to, for example, the PAPI, and will power PAPI the same way as if it's powered by a conventional grid. And of course, solar engine also offers, what it offers is a remote control. So PAPI will be controlled from the tower as if it is connected via cable. Yes, it will give 6.68. It actually can give you whatever you need. It's a matter of a transformation. Yeah. If PAPI requires 6.68 amp, okay, no problem. We can deliver such solar engine. If you need low voltage or you need 230 volt, then it's also possible. It's because this product is modular and it's very flexible. So we can basically deliver whatever current and voltage you need for your product. Okay. So going, yes, the pilot activation is also available. This is let me show you how it works. Now it's actually on the page here. So how we control hybrid lighting? As I said, we do not use conventional grid to control light as it's done in a traditional lighting system. We use wireless network. There is a module that we call control and monitoring module. It's installed in ADC room. It has control and monitoring interface, computer one, that is used actually to control entire system. So the signal, when the controller wishes to activate light, it presses the button here, or it clicks on the interface, and the signal, wireless signal, goes to the light or to the group of lights that it was that it should be delivered to. Okay, and of course, actually, signal does not flow like this way. It's only for let's say presentational purpose. The signal is the entire radio network is built on the concept of a mesh network. Mesh network actually it is very dynamic, and the signal can go like this, or it can go like this. It's actually very dynamic, and the signal from the tower to this light will go the way that it will require the least time to be delivered. I know that when we speak with two airports, they usually ask if this radio network can interfere with any type of navigation. And I can say to you, based on the test, it's based on our applications at commercial airports, that there is no interference with any type of navigation, radar, or ATC communication. How is that possible? It's because, first of all, wireless frequency that we use is 868 megahertz. It's a frequency that is different, and it's different from all typical radio ranges that are used at airports. So, for example, for a VHF communication, you have 118 to 136 megahertz. I don't remember frequency of ILS and VOR, but they are also different. So those are all different radio frequency, and they are not interfering. And also another important thing is that the power output is extremely low. It's 16 milliwatts. We do it like this. Of course, the main purpose was to have radio that will use almost no energy. And also, we wanted to decrease any possible risk of interference. Somebody asked me if we use 2.0 gigahertz. Sorry, yes, gigahertz. This is not the best frequency to use, because at this 8.6 megahertz, you can have much bigger range with a much lower power consumption. For the customer, it doesn't matter. But for us, when we want to have light autonomy as high as possible, it matters a lot. And also, please remember, I saw some companies using 900 megahertz instead of 868. In certain countries, it's okay, but in most countries of the world, it is 900 megahertz. It's a typical GSM frequency that would require approval, because it's only used by GSM carriers. Okay. In case of pilot activation, how it works? This unit here has antenna that is installed on the tower, and this unit, when it receives the signal from the PTT radio from airplane, it immediately sends the signal to the runway and activates entire airfield lighting. Of course, pilot can change intensity 3, 5, 7 clicks. You will have lowest, medium, and highest intensity. And as soon as airfield lighting activated by the pilot, there is no way you can interfere and you can switch the system off from the ground. It's done for the safety purpose. So there is no way to switch the system off from VHF, only to switch it on. You asked if the wireless network is secure. Yes, it's secure. It's actually encoded. So the entire signal is sent with a special code that can only be read by the lights. Is control and monitoring unit battery operated. control and monitoring unit here. Normally, it's designed for internal usage. So it's in the tower. It's connected to 230-volt network. But of course, as we want the system to be as reliable as possible, the unit has inbuilt battery that allows for 36 hours of operations. But this is only in case of a failure of electrical grid. Okay. I will get back to the question of high and low intensity later. Okay. I have a question and I will address it later. Next slide. On the previous slide, let me again show you. I mentioned that we have control interface for the system that we use to provide ATC the same level of control and monitoring that ATC personnel is used to with conventional lighting interface. So here's an example of our interface. It's of course a demo, so it's not a real airport, but we can actually modify and the layout of airfield, and we can modify and to have it designed to be exactly like the layout of your airport. That's not a problem for us. Just for you to, it's a very simple control interface here. So you have, first of all, you can group the lights. So here you can see 5 groups. You have runway, you have approach, you have puppy, you have taxiway, and you have, for example, wind direction indicator. You can change intensity. You asked how many levels of intensity? There are 5. So it's 1%, 3%, 10, 30, and 100% intensity level. You can also choose approach direction. For example, if you choose this approach direction, then we can group the light the way that this approach lights will be on, plane is landing. Of course, you have a puppy on, then we can switch on only this part of taxiway lights. So keeping this, for example, this taxi lights off. This is to provide pilot with some sort of guidance. What else? We can, if you have some meteo information from a meteo station and then we can actually, optionally, we can integrate this meteo information with the system. So we can add the meteo block that will provide you with visibility, with QNH. So, now what you're looking at is a typical interface only for control of airfield ground lighting. When lights are switched off, this is how it is. Yes, so when they on, they green. When they off, they are gray. Okay. Here I wanted also to show you example of the monitoring page. It's another layer of the system. It offers you, as I said, individual light monitoring. So you basically can check every other light and check what's happening. And if in case of failure or some critical malfunction, you can see immediately where it's happening. As you know, in case of, if you have a simple conventional lighting and something would fail, for example, you have this unit out, then you really don't know if it's a cable, if it's isolation transformer is if it's a light you don't know. Here, you know. If there is a failure of the light, and you know immediately which light is that, and you can very easily exchange the light with a spare one and keep uninterrupted operation. Yes, airfield lighting control and monitoring system. This one is a separate from the control unit. You're right. Control unit is like a brain of the system, and ALTMS is the interface. This is, for example, how monitoring feature look like. So in case of failure of the light, you see which light, you can click here, and you see that something is wrong. You can, of course, get into this malfunction and can read the technical parameters. You can see, for example, the battery charging level, and you can see if light is being charged. The charge 1% per hour means that solar panels are providing only small amount of energy at the moment. You have a log file, so you can see historically how unit performed. Of course, you have entire log database in system, so in case of any control required, you can get historical data and offer it to inspectors. Another type of monitoring, for example, when light is not available, it means that there is no wireless connection with it. You see when was it last available, and as likewise you see the battery level. So you basically, you're pretty safe here in terms of visibility of the light. Are there any questions in regards to interface? Prevention maintenance status. Do you mean that can system let you know if something bad will happen soon? Is it what you mean by preventive maintenance status? When product comes to the end of life. The only thing that is critical at this case, it's actually not very critical, because when you have light powered by three sources of power, there is nothing critical here. But what requires maintenance is the battery. So battery should be exchanged every 3 to 5 years. If you ask me, can system let you know when the battery will fail? No, it's impossible, because we can program the system to let you know, for example, that battery has been used for 800 cycles, and then that probably in 200 cycles it should be exchanged. This can be possible, but based on the battery's status, you are not able physically, you are not able to say if the battery is in a good shape or in a bad shape. Okay, can be operational by Hybrid 180 degrees. Sorry, this question I didn't get it. Can be operational. If you mean, can light be something like this? Yeah, that you have, for example, here you have red light, and here you have green light, or you have white and yellow. Yes, it can be. Optics can be directional as well, bidirectional. I think this is what we mean by 180 degrees. Okay. Okay. I see there is a question about cost, about pricing. From the very beginning, we assumed that the commercial questions we would prefer to address via email, via phone. So if you need to have any price estimate, please kindly contact us at our contact details you can find, yes, exactly, at the office solutions for ga.com. To sum up, advantages of hybrid AGL. AGL is the most reliable AGL system in the world. Of course, you can say that you can build system with many loops, but then the system will be very expensive. In our case, we can use only one loop, one CCR, and still have system as reliable as system, for example, installed in Dubai Airport, because it has 3 power sources, because it has control independent from the power, unlike in conventional lighting. If you lose power, you lose control. Here, you might lose your conventional grid, but you will be still able to operate lights and there is no problem, because they will have a battery and the control is done independently by a radio network. And every light in hybrid lighting system has backup power source that will immediately activate the light in case of failure. And actually it means that there is no need of separate generator. In African countries, it's very typical problem for the electrical grid to be unreliable. Suppliers of electricity, they do not really guarantee you supply, and for the airport, it's very critical to light work and being operated. In our case, we supply you with a system that has inbuilt battery, and you need no generator, so it's much cheaper in this case. While using solar energy, airport can save money on electricity bills. As I said, CCR and the conventional grid is used only to recharge units when it's needed, and mainly 99% or 99% of time, the units will use solar energy, which is for free. So the actual savings can be up to $20,000 per year or more. The system is very easy in troubleshooting. As I said, if you have any light out or there's a critical failure, you just take it off the runway and you put spare unit, and that's it. You don't need to check where the problem is, because unless the problem is in the unit, the system will work, because lack of electricity in the conventional grid, it is not critical failure for the system. The maintenance cost is pretty low, as I said. The only maintenance cost that you have here is the exchange of the battery. The battery exchange cost annually is around 2 to 3% of the system cost, of the investment cost. So it's pretty low. Also, in case of this system, you will have individual light monitoring at no cost. The lights are already equipped with it. You have control and monitoring interface that allows you to really have full control and real-time monitoring over your system. And I think what is important is that the entire system, in case of hybrid lighting, the entire system can be sourced from one company. So integration requirement is low. When I say the entire system, of course, I do not mean CCR and the cables and the transformers. But in case if you have already those installed, then the system that is delivered to you is already pre-integrated, because lights are already connected wirelessly. The only thing that you need to do to install, you just install lights to the runway, to the concrete, you drill holes, you install solar engines, and the system can start working immediately. Photometric performance. You asked about photometric performance. Do you mean what kind of output this light provides? If this is your question, then I can say we have 3 types of optics. And now I will talk about runway edge light. We have low intensity ICAO, which is minimum 50 candela. We have bidirectional optics that would provide white light or white yellow. In this case, we have pretty powerful optic, which is 1200 candela. And the third optics is I mentioned that I will get back to this topic. This third optics is Cat1 optic, is a high intensity runway edge light that provides you up to 10,000 candela in the main beam. Today, we already distribute 50 candela and 1200 candela optics, and we are currently developing Cat1 optics, and it will be ready to be bought within 3 to 5 months time. So it should be ready in January to February for distribution. Okay, if you have any question or I didn't cover something, go ahead. Actually, this is almost the last slide. I don't want also you to be bored or sleep during this presentation, so I make it as short as possible, and I hope that if you have any questions that are unanswered, you can always contact us directly. We will be happy to explain. But now, if you have anything that bothers you, if you have any challenging questions, go ahead, please. Yeah, I remember this question that we have high intensity previously asked about, and you tell me low intensity. As I said, we have different types of optics. We have low intensity that is already ready to be bought. High intensity is in development phase. Actually, S4GA is the first company in the world that presents autonomous Cat1 light that can operate without any electrical grid at all. But we have to finish development of this optics. It will be ready in January or February. Go ahead, ask questions. Okay. Unidirectional approach. If you mean, can we provide you optics with one direction? Yes, we do. We will have what you mean, I think, is this kind of optics here that only emit light in one direction. It's no problem. Hope I answered your question, Alexander. How about jet blast? What exactly are you asking about in case of jet blast? If asking if light can withstand the jet blast? If this is the question, let me answer you like this. The light is designed in accordance with ICAO requirement. What I mean by requirements, I mean fungibility. And fungibility has certain limits. So as long as you are within this limit, and then it will survive jet blast. Of course, if you put a jet engine and you direct it on the light, it will probably destroy the light. But the lights that we do are no different than lights that you see from adb-safegate or OCHIM or ATM. Solar panels. Solar panels are installed separately from the units. So I do not see possible for the jet black to interfere with solar panel, because imagine you have edge lights here, yes, and you have threshold lights. For edge lights, you will see solar panels somewhere here, and for threshold, you would also install them on the sides. So, and if you have a airplane, the engines are here. There is no way those jet blasts can interfere with or can influence solar engines. You're asking tough questions in regards to Cat 1. You're asking if we can unidirectional approach Cat 1 light. At the moment, we are not able, because the unidirectional Cat 1 approach would require 20,000 candela. Now we don't have it. We are in the development phase. This will be our second next optics up after we finish Runway Edge Cat 1. Vasileios, I see that you're asking about, you are concerned with solar with the jet blast. Yeah? In case of turn paths, you have elevated taxiway light. Yeah? Can they withstand jet blast? I think they can, because they are designed made of aluminum, made of steel. Of course, you can, in case of solar panels, if there is any risk that jet blast can influence solar engine, there is an option. You can always put them. So let's say you have a turn path. Yeah, you have it here. You have light here. You can put solar engines further away from the taxiway edge to address this issue of the jet blast. So this is why with solar engines independent from the light, in order to be flexible and to mount them where they will not create any kind of danger or cannot be destroyed easily. Fernando, you asked me about XS1000. Now, SP401 was designed primarily, I'm talking about the solar unit. It was designed primarily as a solar unit. It can be powered with electrical grid, but with a 24-volt DC. And no regular conventional electrical grid that you meet at airports is 6.6 amp. So this is why XS1000 unit, it is created to be powered directly by 6.6 amp electrical grid. This is the difference. Are there any more questions? Sorry. How about maintenance of fixtures? How often? Well, there are, I think, two critical parameters in the maintenance of the fixture. So you have, when you have the light, maybe let me get back to the light again, show you what I mean. Okay. In case of the light, what you have LED, you have the battery, and you have all the mechanical fixture. In case of LED, you have manufacturers of LED, they say that you can have it for 100,000 hours. We in S4GA, we prefer to be on the safe side, and we say that life of the LED is 50,000 hours. 50,000 hours is actually, it's a lot, because it means that if you use the system, let's say for 5 hours per night. 50,000 hours mean 20 years. It's actually, there is almost no maintenance here, unlike with the old conventional lights where you have halogen bulb that should be exchanged every 2,000, 3,000 hours. So here it's the huge lifespan. Another part that would require exchange, as I said, is a battery. Battery should be exchanged 3 to 5 years, depending on where you are, on the temperature range of the application, and on the amount of solar energy available at this geographical location. So you can prepare in the worst case scenario that you will have to exchange batteries every 3 years. Fernando, answering your questions, yes, XS1000 can be installed on existing facilities with conventional system as a complement, correct. And if you wish to, for example, just to show the difference, yeah, have a conventional fitting and you have hybrid fitting. Visually, almost no difference. But what you don't see from the picture, sorry for this mess, but I wanted to just to show. Conventional fitting, you provide 6.6 amp electricity, it's working. You switch it off, it's not working. Hybrid system, you have a battery, you provide electricity, the battery is charging. You switch it off on from the remote, wirelessly, it's working using the battery. You cut off electricity, it's still working. Okay. Another feature that this conventional LED light does not have is, of course, light monitoring. So we can monitor battery level. We can monitor if the light is working, and then we can monitor if there is a connection, wireless connection with the light. So there are 3 parameters. Okay. So those are the main difference between conventional and the hybrid. Hope it's clear. Okay. Are light replacement units available? Yes. There are 3 things that you might want to replace in this light. Actually, 3 very simple elements. First one, you have optical head. This is, I call it optical head. You have a radiator, you have optics, and you have LED inside. We supply this entire fixture as a spare part. The cost of such spare part is more or less, let me think, more or less 3 to 5% of the cost of the lighting fixture. So you can easily exchange this part if it fails. Battery, this is very important. We use worldwide available batteries. So we do not use battery packs. We use actually batteries that can be sourced from any country in the world. So actually, airport can source and exchange battery by its own. You are not, let's say, depending on us here. And there is also electronic board. Electronic board can be also sourced from S4GA. What we do in case of, let's say, airport projects where we have 200 lights supplied, we always supply, let's say, 5% of the lights we supply as a spare parts. So then, in case if your customer has any problems, you can easily exchange it on your own. So you don't need us for this. How long will the unit be able to operate if there is no power from the CCR as well as the sun? Okay. If there is no sun and there is no power from CCR, you have then battery that is installed in here in a solar engine. Yes. And you have battery that is installed in the light. You have basically two batteries. This one is more as a backup. This one is the primary source of power of the solar engine. This battery can vary so we can make actually smaller solar engine, or if you want us, we can make a bigger solar engine. For us, it's a matter of requirements of customer. It's actually a matter of requirements of autonomy. If you say, okay, for me, for my airport, I want to have autonomy of 14 days. Then let's say we assume that by night you use light only. Let's say only by night. Then in case of low intensity system, you have 5 hours per night. You have 40 days of autonomy. Then we provide you, for example, battery that will be enough to cover 100 hours of operations of the light in case if there is no sun and no CCR. But question is, of course, is it possible that nobody fixes the electricity for 2 weeks? It is possible. Is it possible not to have sun at all for 2 weeks? It's not possible. And remember, even in a cloudy weather, when there is no direct sun, system will be charged. Of course, the charging speed will drop dramatically, but it will still provide some speed. In case of a shortcut, short circuit, the supply cable, is there any protection? No, of course it's a protection. The fuse is inside of the unit, so it will protect the light against any short circuit. Hope I answered your question. Okay, is there any more? The glass is made of glass or plastic? We have two options. We have a dome that is made. Of a polycarbonate, and we have a dome that is made of a borosilicate glass. And depending on a geographical location, we use either polycarbonate or we use a glass. For example, if you have a desert or a seaside location, polycarbonate will not work. Of course, it will work. It will be destroyed very quickly. So for these locations, like recently, we're now supplying a system for Thessaloniki Airport in Greece. We will provide them with a glass dome. But for our applications in Germany or in France, we would go for polycarbonate. But of course, if customer requires glass only, we can supply with the glass. There are two fuses. What is the material of housing? This one is aluminum, so there is no risk of, let's say, corrosion. This part is made of steel, anodized one, so it's covered with a layer of it's anodized, and then it's also painted. This element here is the aluminum. Now, of course, this outside is the polycarbonate or glass, and inside you have everything protected with IP65 rating. Okay. Polycarbonate, another one piece. Sorry, can you explain your question, sir? Shayudin, polycarbonate, another one piece. Alexander, thanks again, and see you soon in the airport. Thanks for joining us. When you all think of the questions, let me also tell you that in case if some of you will be visiting the shows such as Inter Airport in Munich that will be in October, and also Airport Council International conference that will be held in Mauritius also in October. I myself I'll be personally there, and I will be happy to meet you in person, speak with you, show you the product, so and answer all of your questions that was left unanswered today. Yes, the data sheet is available on the website. For the hybrid unit, please contact us directly at office at solutions4ga.com, and I will provide you with the data sheet. No problem. Okay, guys, are there any more questions and that I can answer? Hope you are satisfied with the information, with the level of the webinar. And if you have any remarks or any suggestions on webinar topic that we can cover, or any ideas about the product that we show, we wish you write us down, email us. We will be very happy to speak with you, because for us what matters is what you as the representatives of a market, of the customers, what you guys think, yeah? How we can make a product better, how we can make a system better. Please let us know. We are always open for any critics or any suggestions. Again, meet us at Inter Airport. Come and meet us at Mauritius. Let's have some beer, some pretzel, and hope to see you soon and hear from you. Thanks again, and have a wonderful day. Bye-bye.